Okay, so in the previous video, I briefly touched on how the quadratic formula works and what the discriminant was, and so I still have it here, right? So discriminant is the b squared minus 4ac that's under the radical. Okay, so that radicand determines the nature of our solutions relative to the quadratic we're working on, right? So when the discriminant is larger than zero, we end up with two real rational solutions. Okay, so when instead, oh, and I forgot to get particular, and if it's a perfect square, right? So let's say that our discriminant, so let's say b squared minus 4ac is equal to something like 25, right? So that is greater than zero, and it's a perfect square. Okay, so because it's a perfect square, that means we're going to get two real rational solutions, and that's because the square root of 25, you know, is going to be equal to plus or minus 5, right? So two real rational solutions. Right now, uh, flip side, if it's not a perfect square, right, but it is still greater than zero, well, what does that mean? Well, let's say we got the square root of 24 instead, right? The square root of 24, that's not a rational number. We don't get a nice, cute square root from that, right? But we're still going to have two real solutions. They're just going to be irrational. Okay, so here we would end up with plus or minus whatever the square root of 24 is. It's going to be 4 point something. Let's see. 4 point, it's about 4.90. So plus or minus 4.90. All we can do is get decimal estimates of that. Okay, so now what happens when it's equal to zero? Okay, so when the discriminant is equal to zero, meaning we literally have, the square root of zero, right? That just means we're going to have only one real rational solution, right? Because the square root of zero is just zero. There's no positive or negative zero. So that means we're not going to have a duality of squares here. We're simply going to have what's known as a double root. And we'll get into that more when we study a little more in depth other kinds of polynomials besides quadratics. Okay, and last thing, whenever the discriminant is less than zero, meaning it's negative, right? So that would give us something. So going back to just using the 5 here, or the 25, let's say we had the square root of negative 25. Well, what does that mean? Well, we haven't gone to that yet. Okay, what that means is we're going to get two complex conjugate solutions, or in other words, non-real solutions, right? And we will go really far in depth on what those are and what they mean in the lesson to follow when we discuss imaginary and complex numbers. So real quick, let's practice calculating the discriminant just by looking at the equation. So again, we see here it's just negative, or my bad, it's just b squared minus 4ac. Okay, so a, b, c. So my discriminant here would be b squared minus 4 times a times c. All right, so minus 4 times a times c. Okay, so we're going to end up with, so 25 plus, it's going to be plus because there's going to be two negatives, so 16 times 6. Okay, so that plus 25 gives us 121. So this is a perfect square, right? Meaning it's going to have two real rational solutions. Okay, let's look at a different one now. Let's look at this second example here. Okay, so 25 now, right? That's b squared minus 4 times a times c. So 4 times 4 is 16. 16 times negative 2, that would be negative 32. Right, so we're going to now have 56. Okay, so This here means it's not a perfect square, and there's going to be two real rational solutions, okay? Or irrational, sorry. Okay, next example. Okay, so b squared, so that's 16 minus 4 times a times c. So 16 minus 4 times 4, so that's going to be 16 times 1 is 16 again, and we get a discriminant this time of 0, right? And we, of course, know that just means we're going to have only one real rational solution. It's going to be a solution that occurs twice because we're equal to 0. Okay, one more example. Okay, so now we have got uh, 16, right? Because that's b squared minus 4 times a times a. Okay, so what's going to happen here? Right, so that's going to be 16 minus 16 times 5, so 16 minus 80, right? And that, of course, is going to give me negative 64. Okay, this means we're less than 0, first of all, and that we're going to have two complex conjugate solutions. Okay, so that's how discriminants work. So that means we would end up trying to take the square root of a negative number, right? And just to kind of give you a little sneak peek at what we'll be doing, that means our solution to this, right, would be plus or minus 8i, right? And of course, we have negative b, so negative 4 plus or minus 8i, all of that over 2 times a, so that would be over 8. So we would get imaginary solutions here. And like I said, in subsequent lessons, we'll go a lot more in depth on imaginary and complex numbers. Goodbye.